Alright. So this is probably the third, fourth, fifth video on the channel. Don't know. But all I can tell you is that this is the first video I will ever post on YouTube with my face on it. I will make more videos, probably, if I have the motivation to do it. I'm gonna be entirely completely honest. I made this video out of boredom. It is currently, I don't even have a watch on me. It's like what? It's 11:30 at nighttime where I live, and I have nobody to talk to, so I'm just doing this. So what I have here are components of a robotic arm. This are the 3 parts for the base, and I made it 3 parts for easier assembly, easier maintenance, and convenience. So the parts that usually slide on here are 3 pieces. You have a servo, the Arduino, and the breadboard. And I will explain its assembly and designs and what modifications I'll make for future prints. Okay, so this is the first piece of the base, the very first layer. And this is where all the components go. The Arduino will be here. The breadboard, which will also be your controller, is gonna go here. Servo will go here. And there's a little hole. I don't know if you can see that, a little hole over here. Cause you see this? This is where you plug it in. And if I bring it, oh shit. So some of my tools. Don't know why I keep there, but some of my tools. This little plug here fits in here, in which you will need it to download your phone. But this design is completely wrong because I can't even like fit this in. Like I can't force it because then I'm gonna break something. I just printed this wrong, and so I'm currently reprinting this piece as we speak. And the modification is I made the hole a lot bigger so that I can finally plug this in properly, and that's for that. This is where the servo goes, and as you can see when I put it on, by the way, this servo has 180 degrees turning, it's not 360. I'll put this in, right? This circular attachment is in center of this base you see here. So the next modification that I put, which is in the next print, is that the servo will be turned this way, because then it'll be more centered. Not going to be accurately centered, but more centered. And I can't do that because of this wiring. Explains the opening that you see here. I don't know, can you see that? I don't know. So that's that. This little piece here separates the Arduino and your breadboard. And the reason for that is because without it, the components would be sliding around. I mean, yeah, they still slide around, but they wouldn't slide around as much without this. And essentially, this is just for convenience. The kind of idea here is that you're gonna have your servo. So you have your robotic arm, all that jibber jabber here, all the wires connected here. I just need to get my hands on a wire stripper and a soldering machine and how to actually properly operate one, because I don't know how to, but I will in the future. Trust me, I will in the future, guys. And I'm gonna modify those wires to perfectly fit within this base. So if I had all this stuff now, this wire would probably be cut here. I'm gonna need wire stripper, wire reels, soldering machine to get the wires to perfect length to fit well within this base. And so the thought is you have your analogs, which you read from your potentiometers, which I don't have. You have your digital inputs from the servos. With that out of the way, we will get to the another 3 layers. This is the second layer of the robotic arm, and as you can see, the top here is up. You wanna know why? Because when I printed this one, right? I'm just gonna get this out the way. When I printed this one, right? I printed it down. So the supports are here. And I just recently got a new PLA filament. And with this specific filament, I don't know what brand it is. It's yeah, I low-key forgot. Oh, Sunlu. PLA filament. I got it in great color. With this one, when it sticks on, it sticks on. With the old PLA filament that I used, the supports, right? I can just like nick at it with a nipper at the corners and then rip the entire thing off. With this one, I have to leave it on the bed. And let it heat up for that plastic to get soft. Then I have to nick at it piece by piece with the nipper to get everything off. And that's not the end of it, because there are these little grid pieces that were part of the supports around. So I've been at it, chipping it away with a flathead screwdriver, like that. And explains all these like plastic little stuff on my table. And yeah, I named the robot J-Max MK1R. Yeah, such a badass name. J-Max meaning like Jaden's machine, and then MK1R, the Mark 1 revived, because my first robotic arm was a finals for my robotics class. And I thought, you know what? If that one was a fail, why not just remake it? And that's what I'm doing right here. And this one just slaps on top of the first layer. Oh yeah, another problem with my printer is experiencing lifting. I don't know if you can see the uneven surfaces at the side, but that's lifting. It's something that we don't like when 3D printing. It's probably a temperature problem, most likely. That's actually probably the actual answer to that, because I printed this at 220 degrees on the extruder, and then I had an 80-degree bed. Yeah, I'm low-key retarded for that. And then you have your third layer, the cap. This one just slaps on the piece over here. So it hides all those wires, hides all those computers, all the other stuff that you don't want to see, and keep this robotic arm base look neat. Now, with that out of the way, right, I will show you the first one. Within this very box right here is the first robotic arm your boy has ever made. And before I get into this, there are missing components to it, because this Arduino right here used to power this robotic arm, and now she's just a full mess. Boom! This is the one I printed for finals out of my robotics class. This was the robotic arm here, and as you can see, the assembly is beyond dog. Beyond dog. Look at this. It's that side. The servo is like screwed in there. I don't know if you can see it from the lighting, right? But it's like on a tilted whatever. And that's the robotic arm. This was the housing for the Arduino that I made. I don't know. Oh, the wires came in through this hole and we'll plug in here. And this box was supposed to be for the plug, but I got my measurements wrong, so it can only fit this piece, not that one. This is the cap that goes on top, right? J-Max MK1, I told you. That's the point of the MK1R. That's the revive. This is the one that started it all. This was also on PLA, but the bed, the printer I printed this on was Inventor. I think a Flash Forge Inventor. And the thing with that printer is that you can't remove the bed like what you can on my printer. Like you can remove it, bend it in all sort of ways to make it easier to get the model out. This one, no. I had to heat up the printer. I had to heat up the bed. Oh shit, that's one of the wires. I had to heat up the bed and chip it away with something. I forgot what you call it. And explains why this one looks so bad. So bad quality print. And the idea behind this is that there are two switches, here and here. This is an on and off switch. This is a factory reset, what I like to call last year. Essentially what it is, so you could have the robotic arm like this, right? And say you want to bring it back to home position. The home position for it was like a jagged like stack, kind of like this. That was the home position. That was the point of this second switch, but it never worked for my code. I don't know why. So I ended up passing somehow the finals, and with my robot, I shit you not, only this joint was moving, and it was moving violently, like it was shaking, like when someone is seizing, right? That was this joint right here. When I moved it with the potentiometer, it was shaking violently, but still operating. And I guess that could be to how low quality the potentiometers were. I mean, my teacher said they were like 1 cent potentiometers. This is the control. It uses a really long breadboard. And now I'm going down to a small one. It can fit all 5. My fingers are tiny enough. I'm telling you, fingers are tiny enough. And if it isn't, I'll probably just change the design again. I'm too dumb for this shit. So that's the controller. This is the housing right here. And you'll understand and see why the base is now in one piece and rather than 2. Like, this is all the base. This entire thing, the actual base, controller, computer, you're gonna understand why I printed all in one, right? 9th grade me could not understand shit like that. So, that's that. This was the base. And this was for the servo to go on top. No. This was the wiring I used, so I'm just gonna dump that all out. Look at this. Look at that. Look at that. Oh, nasty. So, servo goes here. Wait, let me check something. Okay. So, where the did I put the? Oh, it's right here. Okay. This is your servo, and you put it right here. Right, it has a nice perfect fit to it. Moves a little bit, but that's fine. I wrapped it around the base. Actually, I didn't actually wrap it around the base. No, I feature this hole here, and boom, right. Then you have your shit on top, right, and the idea behind it is you see the wires on this one. That one goes on top, and the wires from those servos go through this wire. So, in through here, and not through this way right here. That was the idea with this one. And, yeah, that's all I gotta say for that. In summary, the MK1 was ass. Actually, not even ass, beyond that. It was so bad, now that I look back at it. But, I guess you couldn't blame me. You probably still could. Because it was a finals, and also, I think we only had like a month and a half to do this. And me not having that kind of brain powering and bit processing, the teacher still gave me 100 for the effort. As for printing goes, this is the new base for the MK1R. I'm printing so far on this K1 KP3, yes. Slow printer, yes, I know. But my dad bought this for me on his birthday. And that's what makes this printer so special. And even if I want a new one, I would never abandon this one. I would never. This is probably just going to be somewhere in a box. You know, I might use it if I get a new one, but no. Very limited printer. And like I said, this one you can remove from the bed and bend it in many ways. To get this model off. It's very gold and very beautiful, yes. Probably robbing me to touch the bed because now my fingerprints in there and the bed's probably gonna fuck up. But yeah, that is the base. Oh shit, I'm running my phone already. Holy. But this is the filament I use. I have more down in my second drawer right here. Penlu Lab. What is it? It was Sunlu. That's just the name of the brand. I don't know if they sell printers. I never researched into them. But my parents bought their filament. My dad specifically. And thank you, Dad. I got 3 reels. The one back there is gray. This is also gray. And this one is black. Maybe I should get color variety, but I don't want to be too expensive on my parents though. I think this was like $30, along with like this mini scale that I bought. This mini scale I bought for NASA Hunch, and for you nerds who actually know what NASA Hunch is, you'll understand what I'm talking about. They have a lunar additive project going on. So that's the progress on the MKR versus the MK1 stuff that I'm doing with 3D printing, how everything's going so far with this project. I hope you guys enjoyed. I'm not going to tell you to hit that like button or none of that, because I know this video ain't going to get that kind of views, but I hope you guys enjoyed. Peace, guys. Stay safe. Download your phone. The top here is up. You're for that. Just a full ass dog. Beyond dog. Look at this. Look at. Oh shit, that's one of the wires. I shit you not. Don't do this. Stand like that. Look at that. Oh, where the did I put the? Oh, it's right on top. Oh shit, I'm running my phone already.